Hi, I'm Vibeke Sorensen, an artist from California Institute of the Arts.
And I'm Mercurio, a programmer here at the San Diego Supercomputer Center.
And we've been working together on a National Science Foundation funded project called Interactive Stereoscopic Imaging. I'm a co-principal investigator with Dr. Lynn Tenite, a crystallographer. And we're working here in the Advanced Scientific Visualization Laboratory at the San Diego Supercomputer Center on this project. And the first half of this project involves the development of a new input device and user interface, which Phil has been building over the past year. And I would say part of the background is that visualization problems basically are often the same in various disciplines, for instance, between art and science. And that is one reason why I, as an artist, am working together with Phil and other scientists like Lynn. The idea is that one can bring paradigms from other fields such as the arts or interacting with space to bear on these new input devices and new user interfaces. And this will hopefully improve our ability to interact with complex computer models.
Okay, let me explain the setup we have here. The equipment we have here is a Silicon Graphics Iris workstation, a 4D 210 with VGX graphics. The software we're running is an application I wrote called Stereo Preview. It interacts with the Wavefront commercial animation package called the Advanced Visualizer, and in fact is a substitute for part of Wavefront's animation package. This program actually has two different modes that it runs in. The mode that I'll demonstrate first is for viewing a single object and interacting with it in stereo. We also have a mode for scripting an animation in stereo. I'll show you that too. This is SPV in object mode. We have a couple of sliders here that allow us to control some of the parameters in stereo. The convergence plane, which is the point at which the two virtual eyes meet in the world that they're looking at, and the eye spacing between the two eyes. As you can see here, if I separate the eyes quite far, you can clearly see two different images on the screen. If I want to see this image in stereo, I wear these glasses. These are liquid crystal shutter glasses. They're synchronized to the display here by an infrared beam emitted by this box and received here on the glasses. So when the iris is displaying the left eye view, these glasses have the right eye shutter closed. When the right eye view is being displayed, the left eye view is blocked. This happens at 60 frames a second, so I'm seeing a 60 frame per second image per eye. What I'll do for the purpose of this videotape is I'll bring the eye spacing down so it looks to you as a monoscopic image. This is a device that we've called Banana, primarily because it's yellow. It has mounted on it a Polhemus IsoTrack tracker. This is a 6 degree of freedom tracker. The hardware here can identify or can localize this device relative to the receiver in a 2-meter hemisphere with about a 1/4 inch accuracy. It can tell not only the X, Y, and Z location, but also the orientation. So it records 6 degrees of freedom. The tracker alone isn't sufficient for interacting with an application. We need some way to issue commands. This device, the Banana itself, is built from a toy guitar. It has 12 buttons on it, which are being read by a simple I/O board inside an IBM PC. The IBM PC and the controller for the Behemoths both talk to the iris over serial connections. Notice that the buttons on the banana are labeled in the same way that a telephone keypad is labeled, to try and give the user something as familiar as possible in their hand. With this device, I can issue simple commands such as bring the windows down, bring the windows up. I can also control the rotation and translation of this object. We found that it's handy to have one button that does both rotation and translation, one that does rotation alone, and one that does translation alone. So if I want to move this object into the screen, I press this button, I push it in. I'm only attached to the object while I'm pressing a button. We call these grip buttons. This way I can move freely in space and only grab the object when I want to. The object will always follow my hand from the point that I press the button. If I want to rotate it, I press this button and turn it. If I want to both rotate and translate, I press another button. And I have a reset button. Another thing that we discovered in experimenting with this is that positional movement isn't sufficient. It's nice to also have velocity control. So we've got a separate set of buttons that do the same functions, but control the object continuously. So if I pick the continuous velocity translation button and just move slightly forward, the object will continue to fly forward or into the screen, or make any other changes. I can also do continuous rotations. This part of the program can display any wavefront object. It can be used to preview an object prior to using it in animation. Now let me show you SPV in preview mode, in animation mode. This is SPV in animation mode. It allows us to preview and script an animation, which can then be rendered by the wavefront rendering software. This program is compatible with the file format read by wavefront, so that we can use either tool to modify the animation. In this tool, we're able to see two camera views of the animation in stereo, again using the stereo glasses. That's why you see ghosted images here. We have many of the capabilities of Wavefront's preview built into this program. I have a list of the objects in the scene from which I can select one to edit. Here I'm going to select an object which is called Venus in this display. This is a solar system simulation. And I'm going to attach it to the tracker. When I do that, I can see the current values displayed here, and I'll see those updated as I animate. This animation consists of 100 frames. I can set a keyframe or point at which I'm going to position the objects in the scene using this control here. So I'll set some keyframes at frame 1, there's one at frame 28, one at frame 60, and one at frame 100. See what the animation looks like before I start modifying it. I'll hit the play button. And you can see that things are rotating around, and this object is moving along with the others. You can see here visual representation of where we are in the animation. I could also interactively set the stop and end points in the animation. Let me stop it here and go back to frame 1. And let's start making an animation. Several of the buttons here that relate to moving through keyframes and saving keyframes are also duplicated on the banana. as I described before in object mode, I can translate and rotate an object using the banana as an input device. So for frame 1 here, I'll grab that object and move it around. Notice that regardless of the animation's effect on the object, the movement is always with respect to the user's frame of reference, not the object's frame of reference. So I can position this object, let's move it way down, and mark this as a keyframe. Let me bring up the keyframe list again, so you can see that. And I'll mark this frame as keyframe. That keyframe turns red. To advance to the next one, we're now at frame 28, and we can again position this object's location for this frame. Let's rotate it around a bit. We're setting its rotation relative to the Earth, to the Sun, excuse me, and translate it. If I want to, I can get rid of all the buttons and panels in the scene, so I can concentrate on just the animation. That's a good enough spot. We'll set that keyframe. See what our panels look like again. We'll advance to the next frame, 60, and move the object again. And set that keyframe. And advance to the final frame and bring the object over here somewhere. The motion for that object has now been set at 4 frames. To calculate the frames in between, I can do either a linear or a spline-based interpolation. I'll do a spline-based interpolation, which is now complete. Get rid of the keyframe list, and let's play the animation and see what we have. Notice that it's passing through each of the points that we set before. Each of the objects in the scene were scripted in this manner. And since we can see the animation in stereo, or at least I can see it when I wear the glasses, I can see when objects include each other and get a better feel for what the final rendered image will look like in stereo.
This is some of my animation. This is a test file in Stereo Preview where the objects are both geometric and organic in shape. The organic ones are filtered through a program that takes some of the triangle, so it doesn't have the whole shape. But I use this program to help me position dynamically the objects in space. And this is a great improvement over the way I did it before, where I would preview freeview, that is, 2 smaller images side by side to try to figure out the depth. Then I would have to use each parameter independently, each transformation parameter, and gradually move the objects to the correct position of depth. Now with this program, because the input device has 6 degrees of freedom, I'm able to dynamically move the object to the correct place in the space just by moving my hand. Also, I am working in the correct scale image for my final display, so I don't have to do any guesswork about what will happen when the image is blown up to monitor size. And this is further improved by working with the screen size image, where it is essentially human scale, so my human scale movements can translate well into the 3D space, and I can, in a way, immerse myself in the environment, and that's the idea. And I'm more able to work, I'm able to work better in this environment because the images are my size. And when the final viewing scale is a screen size, it makes sense to be working in the same size because my decisions are better. And I can see it in 3D because I am wearing these stereo glasses, and I don't have to do any guesswork, and I know exactly where things are. Also, I'm able to work with more minute movements of my gesture and know exactly how that translates into the space. So it's a big improvement over the old way. I hope you'll come and see us. Thank you.